Approximately, yes, ma'am.
Approximately means few are left.
Yes, ma'am.
Okay, then we'll wait.
Yeah,
Takeout room are closed, but they might have like logged out because of some reason. So you may continue.
Okay, then I'm continuing. Maybe they'll have the recording, so they may see the missed part. So
Yes, yes, ma'am.
after this, we are going to start the comparison of mean and median between two groups.
Ma'am,
And
can I ask something?
yeah, please.
Ma'am, if we are taking the correlation, for example, in the data set, there is a correlation between BMI and cholesterol that we are taking, ma'am. So
Mhm.
if we are taking that two variable independently, we can see that these are not significant. The p-value is not significant. But if we are taking other variables with that, showing significance, ma'am, what is the reason behind that?
So now can you show?
No, not sure.
It's-
We will explain. वो एक variable दूसरे variable को affect करता है.
So that means you want to say that one variable is affecting the other variable. That's how the value and significance is changing, right?
Yes, ma'am. Like in logistic regression, if we are doing, you can do like taking a single variable and then we take the multiple variables.
Yeah, that is there. That is the natural phenomena because you have to take the all the variable into consideration, and that's why you see that there is a difference in the correlation coefficient or maybe the significance level. So that is because of the multiple factors which you are considering.
Okay, ma'am. Ma'am, shall we mention that in our papers too?
Yes, you may mention if the correlation, if your primary research question involves the analysis showing the correlation matrix, then yes, you can. You should.
Okay, ma'am. Thank you, ma'am.
Okay. So now coming to the comparison, there are various tests, and if you want to compare the mean or median between two groups, then what are the various choices with us? So you can see here that there are various tests which are there to compare mean and median. Okay, there's Dr. Varalakshmi is asking, there's one doubt from the previous session, how to convert a categorical variable to a quantitative variable.
ये तो convert है.
No, it's reverse.
नहीं, quantitative थोड़े
No,
होगा.
no, you are saying
Cannot.
we cannot do that. Yes, that's what Dr. Selva Raju is writing. A category which is essential a qualitative, let's say gender. So you cannot convert it to continuous. That's why maybe there's one point which I want to emphasize. We have experienced this with many PG students, especially that since beginning they make categories of maybe the income or maybe the age. So please don't make a categorical variable since beginning if the inherent nature of the variable is quantitative or the continuous. I want to say that once we received a data set where the student has already made a category like 20 to 25 years, 25 to 30 years, 30 to 35 years, and he has put individual in those categories. And now then he like came to us. So you should not do that. You should always take the variable as a continuous. Later on, you can make any variable. Yes, one PG from Gandhi also came with that value of low birth weight and normal birth weight, or maybe the high birth weight. So since beginning, she has made a categories like less than 2.5 kg. Then you cannot perform many analysis if since beginning you are making categories. So with this, I just want to, this is a good question, that don't take a variable which is essentially a continuous variable capture, because you have seen the authenticity of the data. If your variable is towards continuous, the level of evidence will be more. So don't take the categorical data if the initial, don't make the category since beginning, even if the socioeconomic status. Don't write like upper socioeconomic, middle and lower. You just write the per capita income or all those variables, whatever scale you are using, take that into account, and later you can make many things out of that. Okay.
Okay, ma'am. Okay, understood.
Okay. So, and this is a very common mistake which the clinical people they do. Like maybe many of you also have experienced, I'm sure, because people are same everywhere. So I don't know why they think that they will see the output in the table, like they read manuscript and then they see that there they have defined the categories. So since beginning, while data collection, they make the category. And then they say that, but ultimately, like Dr. Selvaraju is writing, you cannot convert it to any continuous unless you have the raw data. So good. Thank you for pointing this issue. And then, so now coming to the various options which we have, like there are various options like one sample t-test also, like there was a goodness of it chi-square, but we are not dealing that because that's not often done. Rather, I have never seen putting anyone like applying this one sample t-test. So it's basically we want to compare it between two groups. So independent sample t-test is one such option where you want to compare the mean between the two groups across a categorical variable. And its non-parametric counterpart is the Mann-Whitney U. Again, no need to remember the name. Why? Because in the same interface, you will see that you will find the name of these tests. So even if you don't remember the name of the non-parametric, no problem. You can just see the Jamovi and it is right there. Then coming to the, if you want like a paired observation. So what do I mean by paired observation? Like we have seen just for the correlation, here the pair means like same continuous variable measuring twice on the single individual. Here we mean the paired observation. And then its non-parametric counterpart is the Wilcoxon-Sign-Rand. So we'll see that in the third session. So currently we'll be talking about the independent sample t-test. Again, I should say that this is one of the most commonly done statistical tests in especially in the PG thesis, because they always, like especially from the clinical side, some parameter is there and there are two groups, or even the ANOVA more than two groups, then independent sample t-test and paired and repeated measure also. We are not covering the repeated measure and ANOVA because of the paucity of time. But again, you can see our videos, which are there in the YouTube channel, and we are not confident that you people know this Jamovi interface. So this is very simple. You just keep on clicking the various options and you'll come to know. So now coming to the independent sample t-test, the basic concept, if you want to know, like here we are writing independent samples. So yesterday also, I think one person asked like, I should be telling more about that husband and wife type of sample. So I'll emphasize more on that today also. So here I'm writing like the two groups or the two, like if I say across gender, so the two groups should be independent. Now, what do I mean by independent? That means they should not be related somehow. Related means, like I said, husband and wife. If yesterday we talked about that binomial proportion of heart attack. So 50% male and 50 female. So if I take 50 husband and wife pair and see the heart attack in both male separately and female separately, then this male and female group, they are not independent to each other. Why they are not independent? Because they are related to each other. So that's why they are not independent sample. Similarly, we call this with the twin pair also. In many of the immunological studies and genetic study, you see that twin, we take twins. But if you like, if there are suppose two twins, you take one twin in one group and the other in the other group, then also they are related samples. So independent groups means you select the samples from the population and one person should not be related, means some genetically or some by some marital, like because they will be sharing many things, many pattern together. So that we mean by the independent groups or independent sample. Did you get that? I think I don't remember the name, but one person yesterday also asked regarding this.
Myself, ma'am, Dr. Bharat.
Okay, Bharat. So is it clear, Bharat, now? What do you
Yeah,
mean?
ma'am, 50% clear.
Okay. So the 50 remaining, can you tell
No,
me?
what I mean to say, should we ensure that they are not wife and husband or not related while collecting the data?
Yes, yes. In the sampling you mentioned, remember in community medicine, we always mention that we will go to one house and we'll select how we are in that house, how many individual we are selecting, one or more than one. So in that sampling, that's comes the role of sampling strategy or sampling method. Because sample size it is okay, but how you are going to take those study participants in your study, there should be clear cut direction or there should be clear cut mentioning of these things. So we do mention that if there are 4 eligible participants in one family, I'll take one randomly out of that. If my study involves like maybe a spouse, this thing, then I will definitely take both. Up to it depends what is my research question. If my study unit is husband and wife, then definitely I'm going to take those 2 people. Like if I'm doing something on contraception or maybe anything. But if my study unit is individual,
Just
then I will count that individual as one and I will mention that if we are doing a household sampling. In case of clinical, this thing definitely also you will write that if husband and wife both are coming for the same disease, but that rarely happens.
Yeah.
That both are coming to this thing. But if it is there, then you take one out of those 2. Because otherwise this independent group assumption or this criteria will not be met.
Thank you.
So now I hope you are 100% now that remaining 50%. Are you clear?
Yeah, yes, ma'am.
Okay, thank you. So this independent, that's why the name is the independent sample t-test. And then your t-test, because we are comparing the mean value and the distribution or the test statistics which is used here is the t-value. That's why it is the t-test. So now the research question, the various research questions for which we need this independent sample t-test to answer. Like if my research question is like, is average BMI value of population with history of cardiovascular disease is different from population without history of cardiovascular disease. So that is the, here we will apply the independent sample t-test. Now coming to the second type of research question, which is the comparison of pain score. So if I have taken pain score on visual analog scale, in the 2 surgical techniques, surgical technique 1 and surgical technique 2, and I just want to compare where the perception of pain is more or less, or what is the mean difference in the perception of pain, then I may use this test. Or if my research question is like, do medical undergraduate students who have good quality of sleep score high in exam as compared to poor quality sleep? So this is again a type of, you can say, a research question where you are comparing in all these, you will say that there is a continuous variable. So continuous variable is the score. And then categorical variable is a good quality sleep and a poor quality sleep. Similarly, in the research question 2, the continuous variable is a visual analog scale. And the 2 categorical variables are surgical technique 1 versus surgical technique 2. And here also in the first research question, you will see that the 2 categorical variables are with history of cardiovascular disease and without history of cardiovascular disease. And you see the BMI. So this may look very simple to you, but the PG student, they get confused initially, like how to go for this categorical and discontinuous. So the basics of the type of variable, that is very important to understand the applicability of the various statistical tests. So Dr. Selvaraju is asking, what about the cluster sampling and analysis? So cluster, for that we run a cluster module, and depends whether it is a cluster randomized trial or it is just a cross-sectional study. So for a cross-sectional study, if you are like doing some immunization survey or something like that, then we do it together. But for randomized control trial, if it is a cluster, then definitely the analysis is somewhat different. So coming to the other, in all these things, what have you observed? That there is a scale variable or a continuous variable in each of these research questions, and we want to compare the mean across the 2 categories of a nominal variable.
Ma'am, for scale variable, isn't median better than mean?
Dhanya, can you repeat your question for a scale variable?
Isn't median and this man with me you better than mean and independent
why?
t-test?
But why? Why do you
Because
think?
is there any meaning for that 1.2 or 1.5 if it is a scale that is visual analog scale 1 to 10? Is there really a meaning for 1.5 or 2.5?
Okay, so here scale variable, I mean to say that any continuous variable. It's not that scale like PHQ scale or visual analog scale, Likert scale.
Ma'am, is it a ordinal scale? Visual analog scale is an ordinal.
Agree, visual analog scale is an ordinal scale. But here so is your question only pertaining to my second research question, this one? The second one?
Yes, ma'am.
Is your question is specifically on visual analog scale or for all 1 to 3 research question?
Specifically, I was thinking about visual analog scale.
Okay, so for visual analog scale, okay, here this scale I'm taking is because yesterday I said that ordinal variable, you can treat them as a continuous variable. So it is not necessary that you take the median. And here you will see that we have to, before we go for the independent sample t-test, we have to check for the assumptions. If this scoring in the visual analog scale, if it does not follow normal distribution, then definitely you have to go for the median. So choice of test, whether it is Mann-Whitney U or a standard T, that will depend on the assumption testing. Is it okay? Okay. I think there's one more question. If I take elderly husband and wife from a family for studying cognitive impairment, they are not independent. Yes, they are not independent. That means you want to understand. So your study unit will be both husband and wife. Like many neonatal or that under infant study, we do it on mother-child. So we take both mother and child as a pair.
They are not independent.
So here in the, yes, they are not independent. And your study unit will be your spouse. Both spouse means that pair, husband and wife. Right? They are not independent. Agree. So in all these cases, you will see that there is a continuous variable in each research question and you want to compare the mean of this across two categories of a nominal variable. So appropriate statistical test for such type of analysis is the unpaired t-test or the independent sample t-test. So this is, you can see that this is also known as the student t-test, between subject t-test, or the unpaired t-test, because there is a paired t-test also. So it is also known as the unpaired t-test. So there are various possibilities of the research design. If you wish to apply such tests, we'll see what are those research designs. So if you have taken two independent groups and you want to see the median difference between these two groups, like this is these are, you can say, 7 individual. I have measured cholesterol level in these 7 individual and I want to compare the mean cholesterol level in male and female. So then what will I do? I will go for this independent sample t-test. The second research design can be, I want to see the difference between the two intervention. Like there are, it is a randomized control trial where I have people in the intervention group and the people in the control group. So what I'll do, I will compare the difference in the cholesterol level in the intervention group and in the control group. So if I do like that, then also it is I have to apply for the independent sample t-test. You can measure the change also, the third, which is a third research design. Like there is something at the beginning of the research. For example, I have taken, this is again the same study, randomized control trial, where I have done some intervention. So I have measured the cholesterol level in the two groups before the intervention and after the intervention. And I want to see the change in mean cholesterol level. Like you can see the pre-intervention cholesterol level here. If you focus on these levels, so these are the pre-cholesterol level. And after the intervention or no intervention, this second column is for the post-cholesterol. And this third is the difference. Difference means like, because I expect a reduction in cholesterol, so I have defined difference like baseline minus post. So it should be positive. But you will see that there are some positive and there are some negative. So if I want to measure this difference across these two group intervention, because I want to say like where the reduction was more or control. So then also you can go for this independent sample t-test. Now coming to the underlying assumptions, what Dr. Dhanya was talking. So underlying assumption is like, first is there should be one dependent variable which should be measured on continuous scale. And the second assumption is one independent variable that should be categorical variable. And it should have two categories, not more than two. Because if it is more than two, then we have to go for the ANOVA. So it should be only two categories, that independent groups. The third is the independence of observation. So here we have talked about that independent groups. I have to ensure like the two groups are separate, not related to each other. The fourth assumption is like dependent variable should be approximately normally distributed for each group of independent variable. And we'll check that. This assumption also you can check on this itself, Jamovi itself, in the same interface. And then there should not be significant outlier in the two groups of the independent variable in the terms of the dependent variable. So this you have to go with the descriptive one. This box plot option is not there in the Jamovi, in the independent sample interface. The next assumption is the homogeneity of variance. So the homogeneity of variance, what do I mean by the this is another different assumption, which is a very important assumption to be tested, because that will help you to take the value. There is something known as the Welsh T and there is something known as the standard T. So based on this parameter, you will say that which T you have to report. So what do I mean by the homogeneity of variance? Homogeneity of variance means I assume that the two groups where I am taking, suppose I am taking male and female. So these are the two independent groups if I am studying anything across gender. So variances in these two groups should be equal. That will show that I am taking these two groups from the same population. So that we mean by the homogeneity of variance. Remember, we talked about variance yesterday. How we have defined variance, that it is mean square deviation, MSD. That means you take the mean and you measure the distance, the difference between the mean and the individual value. You square it and you divide it by the n-1. So that is your variance. And under root of variance is the standard deviation. So homogeneity of variance means the variances of the two groups, independent groups, which you have defined, that should be same. And that we test by a test with we'll see what test do we apply. So normality testing, we have talked about this, like Shapiro-Wilk and QQ plot, depending on the sample size. So in case of a t-test, ideally we should be checking the normality across group. But again, this, we always say that t-test is a robust test. So it is not necessary that it should be strictly normally distributed, because there is some problem with the median also. The interpretation of median is somewhat less intuitive for clinicians and for evidence-based medicine as compared to mean. So if it is, even if it is approximately normally distributed, rather than Mann-Whitney, you should go for the t-test. And that's why we always say that you should have an adequate sample size. So that if you ensure that adequate sample size is there, then generally you can prevent yourself from going for these non-parametric tests. The second point is like if you increase the sample, again, like I said, even the non-normal data can be tested using the t-test, because according to central limit theorem, if you increase the sample size, they start behaving like a normal data. And then again, this basically in SPSS, we check for this both distribution also, because in SPSS, there is a, you can say, option where you can check about the positively or negatively skewed. Here also in Jamovi, you can check. So even if the direction of both the skew is towards the same, I mean, if both the direction is towards the right or towards the left, even if the data is askew, you can apply a independent sample t-test. Am I making myself clear? Yesterday, we discussed about the skewness. Remember, right skew and left skew. So I want to say that here what you are doing, you are seeing the distribution of continuous variable across two groups. So in this case, you have to see the distribution, even if the distribution is towards the same direction, like right skew or left skew, both group is showing, you can still go for a independent sample t-test. Now, Dr. Selvaraju is asking, is it not paired t-test for before and after intervention? So again, that confusion is many times it is there with the participants. So you are talking about this example, Dr. Selvaraju? Okay. So now, see what is the research question here. Can you read it again? Yes, can someone read this question, this statement? Maybe Dr. Ajay can read or Dr. Selvaraju can read.
The level is measured in two groups, control and the intervention. Before the intervention and after the intervention, change in mean cholesterol is tested in both the groups.
Okay. So here my, thank you so much. So here my continuous variable is this difference. Remember, yes, if I am checking this 180 with this 156, then I will apply a pair t-test. Are you getting my point? If I am checking this difference in pre and post, that means is there any significant difference in pre and post, then I will go for a pair t-test. You are absolutely right. But I am not checking this difference here. I am checking the difference, the mean difference of difference. Means if I want to say that I have achieved a lower reduction of cholesterol in intervention group as compared to control group. How can I do that? So that change you have to see from the baseline. So my variable of interest, it's the change. It's not the absolute value. So that's why I said that here I am taking this variable. It is the difference in change. That means I am taking this variable. Yes, for pre-post difference, if I want to say that, yes, this 24, like 180 minus 54, this 24, whether this is significant or not, then I'll go for pre-post test. But here, since I'm taking the one categorical variable that is between intervention and control, where the change was more, mean change was more in which group, then I'll have to go for this independent sample t-test. Did you get it? I don't know whether I'm making myself clear or not. Yes, anyone who still has this confusion? This is a normal confusion, and in every workshop, participants have this confusion that they always see that pre-post. But I am not comparing pre-post. I'm only, because here it's that we do when you have got a single, when there is a no comparison group. When you are using intervention on single group and you have done the intervention and then after some time you measure that post level and then you see the change. But here I have got two different groups. So these two different groups are the intervention and control group. And I'm seeing the change in these two groups. So that's why we will have to go for this independent sample t-test.
And ma'am,
Okay.
as you said earlier, they are not related. When we do in pair
Yeah.
t-test, they are related.
That
They
is
are
again.
we are doing in the same individual.
Yeah. Agree. Again, you are very right. Here I am talking about independent sample. And if you are doing pre-post, it is a related sample because the observation, these two are related. So anyways, there you have got another assumption that we'll see in the paired t-test, that it should be related. The sample should be related. So that's why you will go for a paired. But in this case, since I am not measuring the paired value in the single individual, I'm comparing it across two groups, control and the intervention. So now I'll go ahead. So I was talking about this normality testing, and then did you get this? How? Because many times students, see, when we teach this to our PG students, so in the beginning, what they do, even if there is a slight deviation from normality, they are always, tempted to apply the Mann-Whitney-U or maybe the Wilcoxon, right? But you should remember the slight deviations also, since t-test is a robust test, and there are few situations. What are those situations? Even if it is approximately normal distributed, you should go for t-test. Why? Because the intuitive meaning is more rational. The second thing is, if you see the skew, direction of skew, even if the skew is towards the same direction, both are skewed, then also you go for the parametric, that is the independent sample t-test rather than Mann-Whitney-U. And third is, if your sample size is more than adequate. And in thesis, what we advise that the student, we advise them to do if somebody is very hell-bent, no, they want to go for a non-parametric, then again we say that, okay, go for non-parametric, but again, just write one paragraph on this also, independent sample t-test. So that meaning is conveyed more appropriately if you are conveying in terms of the mean, not in terms of the median. So now going to the homogeneity of variance testing in Jamovi. So this we test by the Levine's test of equality of variance. And here we say that the variances in both the population from where the samples have been selected should be equal. So here there is a p-value. And how we test? If the p-value of Levine's test of equality of variance is more than 0.05, we say that the assumption is met. This is like Shapiro-Wilk, where we don't want our p-value to be less than 0.05. But if the p-value is less than 0.05, then what we conclude? We say that the equality of variance is not assumed. So we have to go for the another t-statistics. So what is that? So if there is an equal variance, then we report the standard independent sample t-statistics, its degree of freedom, and p-value. If there is an unequal variance, then we report Welch t-statistics, degree of freedom, and p-value. Did you get it? So normality is different and homogeneity is different. Many times what students, they get confused. They start putting Welch if it is not normal and Mann-Whitney-U if the equal variances are not assumed. They do the reverse because it is in the same interface. We'll see that. But equality of variance, if its assumption is not met, you will not go for Mann-Whitney. Okay, you will go for the Welch T. We'll see that. So the null hypothesis states that the population mean of the two groups are equal, and the alternate hypothesis states that the population mean of the two groups are not equal. Again, coming to Mann-Whitney-U test. So it's the non-parametric counterpart of the independent sample t-test. And there are many variables like SGOT, SGPT, which has got a very high range. And again, like Dr. Dhanya was talking about the VAS scale. So if some scales are there or if any data is there where you are expecting it to be deviated from normality, in that case, you can go with this testing of this Mann-Whitney-U test. And again, but you check the assumption. So in that case, you will see that the QQ plot will be something like that. We'll see this, but it will not be across this diagonal line. So because then I cannot use independent sample t-test. So what should I do? So if I already know that the variable of interest does not follow normal distribution, as reported in the previous studies, or I beforehand plan to compare the median. If my variable, like Dr. Dhanya was saying, that if she's interested in the median, then definitely she can go ahead with checking the median. And that we check with the Mann-Whitney-U test. So it is used when the assumptions of t-tests are not met, especially the normality. And it is a non-parametric test. And it arranges the sample data in a rank order and then compare the mean rank of continuous variable across the dichotomous variable. So here basically that median, if you see that median in interquartile range, that you will not get it from this, you have to go to the descriptive. And then is the median, then what will be the research question? Is the median SGOT level of population with alcoholic and non-alcoholic fatty liver disease are same? The second research question can be, is median post-operative pain as measured by the visual analog scale is similar for the surgical technique 1 and surgical technique 2? Or is median Apgar score of babies born through normal vaginal delivery and cesarean section is same or not same? So in all these cases, what we have observed, that there is a scale variable and I want to compare the median of it across the two categories of a nominal variable. So the appropriate statistical test is Mann-Whitney-U test, which is also known as the Mann-Whitney tests. So the assumptions of Mann-Whitney, again, you can say that there are variables like Dhanya was saying, like Likert scale or some biochemical parameter or pain score. If it is measured on ordinal level and you say you have checked that it is not coming on normal distribution, or independent variable, it should have only two categories like we have seen with the independent sample t-test. And again, that independence of sample, that assumption true holds true here also. And then you write that the dependent variable should not be normally distributed across two categories of an independent variable. Again, the distribution should follow the same shape. So the dependent variable, this is the QQ plot. You can see SGOT where it is not normally distributed. It will be something like this. It is not across this diagonal line. So hypothesis testing, the null hypothesis states that the median of the two groups are equal, and the alternate hypothesis states that the median of the two groups are not equal. So let's see how to run these tests and let's see what are the questions.
मैम
Yes, Shivam, do you want to say
मैम
something?
अगर टू यस मैम अगर टू एक्सरसाइज है मैम फिजियोथेरेपी डिपार्टमेंट में टू एक्सरसाइज होती हैं मैम
हाँ
टू ग्रुप्स हैं
ठीक है
और सेम प्री एंड पोस्ट कोलेस्ट्रॉल लेवल देख रहे हैं एसबीपी या कोलेस्ट्रॉल लेवल चेक कर रहे हैं मैम
हाँ
अगर कहें मैम कौन सी एक्सरसाइज बेटर है तो मैम क्या करें कैसे चेक बताएंगे कि इंटरप्रिटेशन में कि बेटर है
दो तरीका है, या तो तुम 6 वीक्स के बाद देख लो लेवल, जो भी तुम्हारा इंटरवेंशन के बाद कुछ टाइम होगा ना जिसके बाद तुम एक्सपेक्ट कर रहे हो कि कोलेस्ट्रॉल लेवल कम होगा,
बिल्कुल बिल्कुल मैम
तो वो टाइम के बाद तुम पोस्ट देख लो, या फिर तुम प्री पोस्ट का डिफरेंस ले लो, वो सबसे बेस्ट होता है क्योंकि तुमने एक पहले भी तो लिया होगा एक्सरसाइज, जब भी तुमने जो इंटरवेंशन दिया होगा उसके पहले एक लेवल लिया होगा, तो उसको देख लो और एक बाद का देख लो। तो अगर किसी का सपोज मेरा पहले ही कोलेस्ट्रॉल हाई है लेकिन तब भी मान लो मेरा कोलेस्ट्रॉल 300 है और तुम्हारे इंटरवेंशन के बाद मेरा 200 हो गया, तो मेरा चेंज 100 हुआ, किसी और का पहले है 220 और फिर 200 हुआ तो 20 हुआ, तो चेंज किस में ज्यादा है, इसी मीन चेंज को तुम दोनों ग्रुप में देखो तो सबसे अच्छे से तुम कह सकते हो कि किस में कौन सा इंटरवेंशन ज्यादा इफेक्टिव है।
Ma'am, I have one doubt, ma'am. Ma'am, instead of Mann-Whitney, can we use chi-square? If it is that Likert scale, agree, disagree, and only two groups. In where will we use Man-Whitney? Where will we use chi-square? Is it wrong to use chi-square?
See, whenever it is up to you how you want to treat your this Likert scale. Both ways you can do, but it depends like what intuitive meaning you want to suggest.
What is it?
For ordinal, you can go for chi-square. You want to say that there are two groups, suppose let's say male and female, and you are measuring something on Likert scale, which has got 5 scale, right? 5 point. So you want to make a 5/2 table, right? Contingency. What will be the contingency table?
Yes, ma'am. 5/2. 5/2.
But why you are going? I said that for ordinal, this thing you can go for Kendall tau.
Okay. Okay, ma'am.
Because
Okay.
Kendall tau is there to see the association between. Remember in the correlation, this thing also you will see that there is a Kendall tau. I'll just show.
Yes, ma'am.
It
Yes,
is for
ma'am.
the ordinal only. If you see the this correlation, see this is the Kendall tau. Yeah, can you see this? So
Yes,
for
ma'am.
ordinal, you go for this. If you want to see the association. But if you want to see the mean value, see, it depends what do you want to see. For association, rather than chi-square, for ordinal, it's better you use this. But if you want to convey the mean score, and what do I mean by mean? Like, let's say in one group it is 3, and it depends. This Likert item is what point? Like, if it is 7, 9, 11, then it's I have seen like it's better to use it as a mean rather than going it for a categorical.
Okay, ma'am. Okay, ma'am. Because when I had done this in my thesis long back, 10 years back, I had done chi-square without knowing this. That's why I'm asking the question, ma'am.
Okay, okay. So for association, it's better to use Kendall tau rather than using chi-square. And
Okay, ma'am.
now if you are doing it, so I don't know how you will do it. So if you now want to, you can, and that Likert scale item was on 5 item or 7?
Ma'am, that was that Karnofsky performance scale, quality of life indicator. That was a 5-point life scale, and it was comparison of 2 anti-cancer drugs. But I had done chi-square during that time. That's why I was asking, ma'am.
No problem. That is also okay. But the only problem with chi-square in that 5/2 matrix, once there will be very sparse. Like in one cell, you might find that there will be violation because
Yes, ma'am. Yes, ma'am.
it
Number will be less than 5. Yeah.
it will be less than 5. So then you have to do that improvement and continuity correction and all, and then it will be difficult to convey that some intuitive meaning also. But with this Kendall tau, and maybe that's the ideal one. So now you can, if you, but I think you must have published the paper with that.
Yes, ma'am. Yes, ma'am. I have already published that
Oh, that's
long
right.
back.
Okay. Okay. Yes. So yes, any other question before we go to this? So I was
Madam, I have a doubt, madam, that
yeah, Dr. Nitin.
if the independent variable is continuous and dependent variable is in 2 categories, then which test can be applied?
Okay, so can you give my one example? Let me see. You are saying independent variable is
Continuous
continuous, yes, and dependent variable is?
in categories, ma'am.
So you can go for logistic. Because in logistic, this dependent variable is categorical, like binary logistic.
Binary. Okay.
If it has got 2 categories. And if your independent variable is only 1 or more than 1, then you can go for logistic.
Okay, ma'am. If there is only one independent variable and to find out if there is an association, one independent variable and dependent variable which is in categories.
Okay, so one dependent variable. So
one,
you can
one independent variable which is in
continuous
and dependent variable is in categories.
So there is a biserial correlation. Biserial correlation.
Okay, ma'am. And that is available, ma'am, in this software.
I have seen this. Let me check. 1 minute. Regression.
Why is it?
Okay, no, by serial it is not here.
Okay, SPSS it is there, ma'am.
Yeah, yeah. In SPSS it is there. But I
Biserial correlation. Okay.
yeah, by serial.
Yes, ma'am. Thank you, ma'am.
You're welcome. So I'll go to the question. So you have to check the distribution of these parameters: SpO2, cortisol, LDH, and ferritin. So these are the 4 variables. Why I am? Because I just want to, if I want to compare this, I'll have to see this, the distribution. And then the next question is compare at the time of admission across smoking status. So this is my data sheet. If you open this, you can see you have to go with this. Now we are using this. You have to go analyze and open this T. And if you open T, you will find there are 3 options. Independent sample, there's an independent sample t-test, there's a paired sample t-test, and there's a one sample t-test. Can you see these 3 options? So now you have to, and then again, if you come down, you can see this is the dependent variable. So here you will see there is a scale option. The scale option means you can enter the scale variable here. And seeing the size of the box, you can enter more than one scale variable also here. Scale variable means continuous variable. And in grouping variable, you can use like any ordinal or the nominal. So like here, I can go with first I have to check, and coming to here assumption check. This is the box for assumption check. So here you can check the homogeneity test. Homogeneity test is tested using the Lewine's test of equality of variances. Normality test is the Shapiro-Wilk, and QQ plot is again normality testing but with the this graphical presentation. So I'll go move the 4 variables here, and I may do it simultaneously. So this, if you see the continuous variable, so cholesterol, I can see SpO2, and then cholesterol. First, I'll show you with one, or let's transfer everything. Cholesterol, cortisol, vitamin D. Vitamin D, cholesterol, cortisol. These 4 are, and let's say if I want to see it across smoking status, smoker versus non-smoker. So this is my grouping variable. So first table which you see as output, it will give you the value of T. So here it will give you the significance value, and here you can see that this is only true. Before you even check for the assumption, this table is there. So although you have seen this, but you will check for the assumptions. So here only the SpO2 is significant, less is not. And again, here it is writing that Lewine's test is significant, suggesting a violation of the assumption of equal variances. So I'll go here and I'll check for the homogeneity, and I'll check for the QQ plot. So you can see here, in all other, then where is the homogeneity of variance is violated? So you can see that first one, SpO2, where the p-value is less than 0.05. Rest all the assumption of equality of variance, it is met. So that's why what I'll do now, I'll move this to this window, because then otherwise I cannot report this student t-test. So I may take this and I may report this t value and this degree of freedom and this p value. And I may say that this is your assumption for equality of variance. And if you come down, you can see plot this cholesterol also, you can see that this is normally distributed. This vitamin D, you can see that this is not normally distributed. So I will move this vitamin D also in this window, because for this I will have to go for Mann-Whitney. Now coming to the another cortisol, you can see it is approximately normally distributed. So these 2 I can go ahead with the same assumption that there is a equality of variance assumption is met, and the normality is also there. Now in the descriptive, I have assumed that, because see, what is descriptive? Descriptive is the description of the data. So in the descriptive statistics, you have checked everything. So I assume that you have checked the cortisol, the outlier of cortisol and cholesterol there also. So you can go with the exploration and you have to report the we have done for the box plot, this thing. Then you can write here that the mean difference, and then it is descriptive. So you can see here that these are the two groups. You can see that the number of smoker and non-smoker. This is the group description. There are 123 non-smoker and 53 smoker. So the difference mean value of this cholesterol is 247 and 249. It is giving you median also, and standard deviation and the standard error. Similarly, cortisol also it is giving. And then you can see the its p-value also. P-value you have seen here that these two are not significant. Both the p-values are more than 0.05. Mean difference you can see, but it is not significant. So if it is not significant, there is no point in clicking this effect size, because we report effect size only when we achieve this statistical significance. But if just for learning purpose, if you want to see, yesterday I was talking about the effect size. So this is Cohen's d. You can see it's a very small effect size. So this is regarding when the variable satisfied the assumption of normality and the equal variance. Now with the other two variable, which was the, I think, vitamin D. So if you shift vitamin D here, you will see that it, if you see the graph, it is not normal distributed. So then what you do, if you check for the equality of variance, homogeneity test. So homogeneity assumption is met because this p-value is more than 0.05. So you will go for this Mann-Whitney U. So instead of student t-test, you will click on this Mann-Whitney U. And now you have to report the value of this Mann-Whitney U statistics, its p-value. And here you can see the mean difference, 0.40. And effect size, I said that again, since it is not significant because p-value is not significant, so no need to report for this effect size. And group mean and median you can see here. So this is regarding the application of Mann-Whitney U. Coming to the, if it is not met, so like SpO2. SpO2, if you see, the homogeneity of variance, this p-value was less than 0.05. That means the assumption of this homogeneity of variance is not met. So instead of this student t-test, you will go for this Welch t-value. Because the other, you can see, again, if you see the normality also, it is not normally distributed. So in that case, what you can do, you can go with the Welch t statistic. Then in that case, you have to go with the Mann-Whitney U. So here, if had it been a normally distributed, then you would have taken this as Welch t. So you will see that you will have this Welch t, its statistics, mean difference and standard error of difference. So while writing the interpretation, you should always mention the assumption part, especially the homogeneity, normality, and outlier. These three assumptions, because the other two, it's a study design issue, and we know that you know about the continuous variable and the categorical variable. So that you have to write in the assumption. So let's see what we have written. So your table will be something like this, and then you can write here in the description that there were 123 cases of non-smokers, 53 cases of smokers, and then mean SpO2 level across smokers and non-smokers were normally distributed as reported by the visual inspection of the QQ plot to test for normality. So this is just, I am writing the assumptions. And there was no significant outlier as reported by the visual inspection of the box plot. An independent t-test was run to determine if there are differences in the mean SpO2 level. And there was a homogeneity of variance. So we have given both, like there was homogeneity of variance or no homogeneity of variance. In this case, the homogeneity of variance was not met. So I'll report the Welch T instead of the normal T. So this was similarly, if it is there, then you have to report median. But IQR, you will not get it from here because interquartile range, it only gives you median. So you can report median, mean and standard deviation. For median and this thing, you can go to the descriptive, exploration, descriptive. Here you can like maybe like if SpO2, if I move SpO2 here, and if I move smoker, so it will give you like in smoker and non-smoker median. And from here, if you click on this interquartile range, and like if you want so here you can see like median in the interquartile range. This is the median 97 and 5.5, and this is the 93 and 9. So for IQR, because here you will get the median, but IQR you don't get it from this window. For that, you need to go to descriptive. Descriptive, split the variables like this, and then click on the IQR. Is it okay to all of you? So I have to demonstrate the last part. Last which part, Ankita? Can you guide me?
Not the IQR part, ma'am. The SpO2 you had split the file as per smoker and non-smoker.
Okay, so you want to
That
say
variance part of it, could you again explain, ma'am? So let me just say this. So if we are having, we have to check for variance or homogeneity. In case that her p-value is not statistically significant, then we have to use Welch t-test instead of student t-test.
no, it's not. Okay. Yes, p-value is not significant, then you will use the student t-test.
Okay, then Welch test we are going to use, ma'am.
When p is significant. What do I mean by
Okay.
p is significant? Here, this shows
Yes,
variances, equal variance assumed and equal variance is not assumed. This homogeneity test.
Yes, ma'am. Yes, ma'am.
So if p-value is more than, we want this p-value to be more than 0.05. Why? Because the null, like the Shapiro-Wilk, the null
Yes,
hypothesis states that variances are equal. So
Yes,
that's why
yes.
I want my p-value to be more than 0.05. But if it
Okay.
is less than that, that means equal variance is not assumed. If
Okay.
equal variance is not assumed, like in this case SpO2, then you have to report this Welch T,
Welch t
not
test.
this
Yeah.
student's
So if
T.
p is statistically significant, we have to use Welch t test. That means there is
Yes, yes.
significant variances between the two groups.
Yes.
Otherwise, if it is p is not significant, we use independent t test. I have understood it correctly, no, ma'am?
Yeah, you have understood it correctly.
Okay, thank you.
And Bharat is again writing, please repeat p-value as versus mean difference interpretation. I didn't get this question, Bharat. Can you repeat it? Means p-value interpretation and mean difference interpretation means like
No, actually, what just now she explained, that I just want to rephrase it and just want to repeat it.
so please repeat. You want to repeat?
No, I want it to hear from you.
Okay, so should I repeat this again?
Yes.
So
Just to
what?
register.
Okay, agree. So remember, you only need to see, first focus on this assumption check. So you will see that there are 3 points in the assumption check. there's a homogeneity test, and there is a normality. So both this QQ plot and normality test is same. Like you can say that it is the testing objectively and subjectively. Since my sample size is more, so I'll go for QQ plot. So
Agreed.
you need to check both these two separately, and both these not meeting assumption has a separate implications. Homogeneity test states, which is the Levine's test of equality of variance, that states that that independent groups which you have selected, they are coming from the same population. So their population variance should be equal. So its p-value should be more than 0.05. Then only I can say that there is an equality of variance. If that assumption is met, that means if the p-value is here, which is less, but if it should be more than 0.05, then I will report this value, this student detail. I will click this, right? If this is not met, then I'll click Welsh, which I have done it here because the p-value was less than 0.05. So that's why I'll click Welsh, and that Welsh you will see, and that you will write in your description, in your table, in the footnote. You must have seen, like in footnote of the table with the star mark, that you are reporting Welsh T because the equality of variance assumption was not met. And then you will report, and here you can see it is a Welsh T, its statistics, degree of freedom, and p-value. Coming to normality. Normality has got relationship with this Mann-Whitney. If this assumption is not met, QQ plot, then instead of the t-test, because both these Welsh and student, they are the part of t-test. So you cannot go for that. So if it is not normally distributed, you will not report these two. Rather, you will go for Mann-Whitney. Okay. And then Dr. Nitin is writing, we won't get a range of IQR. Yes, you will get it.
Then,
Let me see in descriptive.
then
Yeah. Okay, Bayes factor. Don't go into that detail. Bayes, it's not related. Even we tried to explore it, but we were not very clear. So that's why not telling you currently. Let me check that.
किसी पेपर में मीन,
Yeah, Shivam?
then किसी पेपर में मीन प्लस माइनस स्टैंडर्ड डिवीजन होता है, जबकि किसी पेपर में मीन प्लस माइनस स्टैंडर्ड एरर दे रखे, एससी दे रखे होते हैं.
वो पॉपुलेशन कई
Standard
लोग
error.
वही है, इतना डिफरेंस समझो कि एरर तुम्हारे पॉपुलेशन के लिए होता है और डेविएशन तुम्हारे सैंपल के लिए होता है. सो एरर कम होगा और डेविएशन ज्यादा होगा. एक मिनट मुझे वो देखने दो उसका. You go to the exploration and then you see the descriptive. So descriptive IQR, like, okay, he's saying that IQR from this to this. Can we get like that?
नहीं वो आपको परसेंटाइल निकालना है.
Oh, that you will have to go with this.
क्या है ना
This one.
नहीं नीचे IQR
नहीं,
ऑप्शन
वो तो I have clicked ना.
हाँ,
He wants to write like, let me shift it. बता रही हूँ क्या उसका
Percentile.
सवाल है. So if I like,
that's a range number.
yeah.
हाँ, वो
SPO2, if I shift here and smoker. So this percentile, can you see this 25th, 50th and 75th? If you click this,
एक median.
एक minute, रुको. Yes, you can remove this. So 25th and
ये IQR.
ये भी buffer. This will buffer, then that 50th will disappear. So these. You wanted this?
Yes, ma'am. Thank you, ma'am.
Okay. So then we can go to the breakout room to practice these two options, and all of you please speak out regarding these